All right, today we're diving headfirst into one of the most mind-bending ideas in all of physics. Forget what you think you know about the universe, because we're going to explore this wild possibility. What if we have a hidden, invisible twin?
Okay, so let's just jump right in. Seriously, think about this for a second. What if everything you see around you, every star in the sky, every galaxy we can point a telescope at, what if all of that is only half the story? And no, this isn't some plot from a sci-fi movie. This is a real, honest-to-goodness scientific idea, and it all starts with a major crack in how we thought the universe worked.
So to really wrap our heads around this, we need to go back to the scene of a cosmic crime, you could say. We have to look at the exact moment when physicists realized the universe, well, it isn't the perfect, symmetrical masterpiece everyone thought it was.
For the longest time, physicists held on to this really elegant belief called parity symmetry. And honestly, it makes a lot of sense. The idea is basically that the laws of physics shouldn't play favorites, right? They shouldn't care if something is left-handed or right-handed. If you watched, say, a planet orbiting a star in a mirror, the physics should work out exactly the same. Nature, it was thought, shouldn't have a preference. It just felt right.
But then came the 1950s, and this beautiful, simple idea just got completely blown out of the water. And it happened fast. I mean, look at this timeline. In 1956, two theorists, Li and Yang, had the guts to question it. And almost immediately, a brilliant physicist named Chien-Shiung Wu designed an experiment to test it. By 1957, the results were in, and they were shocking. The weak nuclear force, that's the one that handles things like radioactive decay, it does have a preference. The universe, it turns out, is a little lopsided.
So, get this. The big takeaway is that nature absolutely knows its left from its right. This was a bombshell for the physics community. It completely shattered that old idea of a perfect mirror image universe, and it opened the door to a really wild new question. If our universe has a preference, a handedness, could there be another universe out there that has the opposite preference?
And that question leads us directly to the prime suspect in our cosmic whodunit. It's this incredibly elegant idea that could fix the universe's broken symmetry, a twin reality hiding just out of sight, connected to us only by the faintest whispers of gravity.
So the theory goes something like this. For every single particle in our universe, every electron, every quark, there's a mirror partner in a parallel cosmos. They were born together, side by side in the Big Bang, as perfect reflections. But here's the kicker, the crucial detail. We can't see them. They can't see us. The only way these two universes interact at all is through that one persistent force that affects everything, gravity.
And this table really shows you just how perfect that reflection is. Our universe has a weak force that's, left-handed. Theirs is right-handed. Our cosmos is built from matter, theirs from antimatter. And because their world doesn't interact with our kind of light, it would just be this ghostly presence. Imagine it. Mirror stars shining with mirror light, mirror galaxies swirling right next to ours, but totally, completely invisible to us.
Okay, now you might be thinking, this is a really cool story, but is that all it is? Well, no. The reason physicists take this so seriously is that this one idea, just this single concept, could potentially solve two of the absolute biggest, most nagging mysteries in all of cosmology.
Let's start with mystery number one. Take a look at this chart. This is basically the recipe for our universe. And you'll see that everything we know, all the stars, planets, galaxies, you, me, all of it, makes up just a tiny 5% of the total. A huge chunk, about 27%, is something we've called dark matter. We know for sure it's out there because we can feel its gravity pulling on things, but we have absolutely no idea what it is.
So, this leads to a pretty amazing question, doesn't it? What if dark matter isn't some weird, exotic new particle we have yet to discover? What if it's just normal stuff? You know, the ordinary matter of mirror stars, mirror planets, and mirror galaxies, whose gravity is the only thing we can feel reaching across that veil between our universes. I mean, it fits the description perfectly. Okay, mystery number two is even bigger. It's about why we exist at all. It's called the baryon asymmetry problem, which sounds complicated, but the idea is simple. The Big Bang should have made equal amounts of matter and its evil twin, antimatter. Now, whenever matter and antimatter touch, they annihilate each other in a flash of pure energy. Poof, gone. So technically, the universe should be totally empty right now.
But obviously it's not empty. We're here. For some reason, there was this tiny, tiny little bit of matter left over. Get this. For every billion pairs of matter and antimatter that wiped each other out in the early universe, just one single particle of matter survived. And everything
Absolutely everything we see is made from those leftovers.
And this is where the mirror universe theory offers such a beautiful solution. It balances the cosmic books. See, the idea is that the missing antimatter wasn't missing at all. Our universe just happened to get the leftover matter, while the mirror universe got the leftover antimatter. So when you look at the whole system, both universes together, it's perfectly balanced. That broken symmetry is restored.
All right, so let's shift gears a bit. Let's move away from the abstract physics and ask a question that's just, well, it's fascinating. If this other universe is real, could there be life there? What would a mirror world even be like? Well, mirror atoms would form mirror chemistry, which would lead to mirror stars and mirror planets. And sure, on those planets you could absolutely have mirror life, but its fundamental chemistry would be flipped. Life here on Earth is built using what we call left-handed amino acids, so mirror life would have to use right-handed ones, and that means we would be completely, fundamentally incompatible. If you tried to eat a mirror apple, you wouldn't get any nutrition from it. Your body just wouldn't know what to do with it.
You know, one of the sources I read for this captured this whole concept with a line that's almost like poetry, and I just love it. It says that if this is all true, then the universe is not a solo performance, but a duet sung in counterpoint across the void. It's this idea of our cosmos and its hidden twin, forever connected, but forever apart.
Okay, this is an absolutely incredible story. It solves mysteries, it paints a picture of a grander cosmos, but the big question remains, is any of it true? And that brings us to the final and most important part of our investigation, the search for actual hard evidence.
And believe me, scientists are looking. They are out there right now pushing the limits of our technology. They're making these ultra-precise measurements of gravity, looking for tiny little wobbles that shouldn't be there. They're studying these ghost-like particles called neutrinos, wondering if maybe, just maybe, they can flicker back and forth between our universe and the mirror one. And of course, they're scanning the night sky, searching for weird gravitational effects that just can't be explained by the stars and galaxies we can see.
So after all that searching, what have we found? Well, the honest answer is nothing conclusive. Not yet anyway. For now, the mirror universe remains one of the most elegant, most compelling ideas in all of physics. It's a tantalizing possibility, but it's still just that, a possibility.
And so that leaves us with one final thought to chew on. And this one goes way beyond the physics and into something more philosophical. If our entire reality, everything we've ever known, is just one side of a cosmic coin, just half of a much bigger, perfectly symmetrical whole, well, then who are we? What does that make us?